Welcome everyone to the second episode of Grind-75 Slowrun, where I will go through the list of curated problems and solve them while explaining just as I would in an actual interview. The first episode we went through with first three problems. Let's begin the second episode. The next problem is problem 121. Says best time to buy and sell stock. Uh, you are given array of prices when prices I is the price of a given stock on ith day, and you want to maximize your profit by choosing a single day to buy one stock and choosing a different day in future to sell that stock and return the maximum profit you can achieve. So since we have an array of prices, in order to make a profit, we would have to buy the stock at a lower price and sell it at a higher price, uh, which comes later in sequence. How do we maximize the profit? How do we maximize the profit? We have to keep keep track of minimum price seen so far and maximum profit seen so far. That way we can that way we can earn a profit. That way we can figure out the smallest the minimum price and maximum price which comes after the future, which would indicate maximum profit. So let's code this up. This is not strictly necessary because of the assumption, but still we'll have this corner case for the completion. Oh, my bad. Let's see. Hmm. So, uh, let's try to improve this runtime a bit. Do we really need an index? No, maybe for it. Maybe for each loop would improve this. And let's see. Hmm, voila. So, and since we run through the speaking about complexity, since we run through the list of the array of prices only once. Uh, time complexity is theta of exactly once rather the time complexity is theta of n, and space complexity is theta of 1 because we are only tracking two variables, which is constant space. And also note this Java trick that indexing an array versus for each loop would always offer better performance in production. Let's look at the next problem. This is valid palindrome. So a phrase is a palindrome if after uh, converting all uppercase letters into lowercase letters and removing all alphanumeric characters, it reads the same forward and backward. Alphanumeric characters mean letters and number, and for the purpose of this exercise, we have to ignore any non-alphanumeric character, and the comparison also needs to be done. Uh, Comparison also needs to be done. Uh, in a case insensitive fashion. So, in case of a very basic palindrome check, you would have two indices into the string, one from left and right, and you would compare characters at left index and right index. And the moment they are unequal, if unequal, you would return false. Now, in this case, in addition to that, we have to also ignore also the also we have to also ignore non-alphanumeric characters, and that is plus in case insensitive comparison. So let's get started. The assumption is that length is at least 1, but still let's still, for the sake of completeness, let's still have that initial null check. Let's again, there is no need to need to persist left and right like index where we have index actual index numbers are outside the loop, so we can handle it this way. And we won't be writing any manipulation because index increment and decrement is conditional. Now, test for non-alphanumeric characters. It's better to, technically we could do it later, but just for the sake of efficiency, we would do it right after checking the character. Now this is where you wish for autocomplete, but that's not always like you won't always have it in interview setting. And we want to continue. So, okay, let's sacrifice a little bit of that efficiency for cleaner, cleaner code. Now, one thing I don't remember is if is it too lower or too lowercase. So let's check it out. Too, yeah, too lowercase. And let's see if Hmm. Okay, is letter or digit is also a static method. So maybe it would make sense to switch it to char unbox types. Again, nothing wrong with using it. It just appears cleaner. And at the end, okay, let's test this out. Ah, okay, let's see. And let's test this out. Okay, cool. So let's look at our next problem, which is invert a binary tree. Mm, Given the root of binary tree, invert the tree and return its root. So what do you mean by invert? At every instance, at every node, the left subtree and right subtree get swapped for every node. And this means we could write a straightforward recursive helper which inverts left subtree, inverts right subtree, and then inverts the left and right children themselves. So that's how we do. What happened? Hmm. Hmm. Do I still have? Let me see. Okay. Okay. So my yeah, sorry, my keyboard had just stopped working. Let's see if we need this. Uh, then good old swap. Now let's check. If you want to be cleaner, you could actually merge them together. But generally while using recursion, while using problems with recursion, it's a good practice to have a helper method which actually recurses over itself. Okay, so let's move on. Next problem is Valid anagram. Now the assumption here is that S and T consist of lowercase English letter, and we have to test if S and T, and we have to return if S and T are anagrams of each other. Anagrams anagrams are words uh, which have same letters uh, appearing with same frequency and in different order, like like the examples given. Now here the assumption is that we have assumption is since there are only lowercase letters, we could solve this with a counter. Actually, I forgot to mention complexity analysis of binary tree inversion. So since we traverse the tree only once, and exactly once, time complexity is if number of nodes are denoted by the capital N, the time complexity would be theta n, and space complexity is depth of is just the space consumed by the recursion stack, which is proportional to depth of the tree. If it's denoted by d, that's theta d, and if tree is roughly balanced, that's that's O log n. But worst case is, of course, linear type, the linear space complexity as well. Okay, so let's move on. Let's code a panagram problem. And I'll not bother with corner cases because the length is actually S and T, the length is minimum one. So let's look at let's initialize a counter array. Now integers in Java are initialized to 0 by default. But if the language you are using, like C++, that's not the case, then you have to fill this array with 0. That's an extra step. Moving on. Let's test this out. Mhm. Okay, now about complexity. Since we are traversing the strings exactly once, and another optimization we can have here is, so let's see how does this affect. Hmm, no difference. But anyway, since now in this case, since S and T have the same length, let's denote the length by N. We are traversing both the strings exactly once, uh, which is these first two for loops. The time complexity for that is theta of n, and time complexity for the count, since it's a constant length array, it's theta of 1 or constant. So total time complexity is theta of n, and space complexity, we only have constant space, which is the char count array. So the space complexity is theta of 1. Unfortunately, this is a little too late today. Sorry, my apologies for starting the stream late. Uh, but this is actually very late, so uh, I will be ending the stream here. See you in the next episode. In the next episode, I'll try to finish first those weeks, and I'll try to cover more problems. If you liked this content, if you like this format, please let me know. Please like and subscribe. And if you want me to cover something else, or if you have any other constructive feedback, uh, please feel free to chime in comments, as well as on the Discord server. See you next time. Thank you.